Well, before I start the presentation, I have a van sitting out there. I just purchased that van. On top of that van is one of these antennas mounted and a camera. And you see the camera up on the left side there. Okay? I'm not going to spend much time with this because this presentation was long even before I did this camera business. It's probably too dark to stand over here. Yes, so we got to be able where the light was. Oh, a little bit. Okay. That's all I'm going to show you with that. Okay? To just let you know what's on top of the van. So when we go after this, we go out and look at the van, you can see where that camera was. It's a pan, zoom, tilt camera, outdoor camera. So I'll close that down. Okay, the other thing I want to show you is this. This is a program which is inside this hardware. This is a repeater. We're going to explain that later. Inside of this is this program. These colors are just a nice thing to show you how it feels strength and things. The only thing I do this is because of the sound, which is a little boring, but okay. Now what you're listening to now is a signal that tells me the field strength of the communication between these two units. So when you're setting up these antennas, you move them like this, and this will change frequency. Okay, so that's all I want to show you about that. One other thing is to show you what I'm actually using right now, and again, it's a software that's mounted inside the repeater. These are the units that are out there right now. The bottom one says van. That's the microwave dish that's on the van. The top two are this unit here and this unit here. And if you look on the side of the unit, you can see the field strength here as well. Okay. Right. These units, they say they're a maximum of 15 miles. We've done 12 miles with them, but when I usually start at those distances, I use a 2-foot antenna, which I've stopped bringing with me. Okay. All right, so I'm not going to show you any more of that stuff, but it's in the van and you can see it later. Any questions and things? Okay, so now we get to the presentation itself. Okay, first let me say on this presentation, everything I say and all the equipment I use is on the website. So you don't have to take notes or anything. And the airport will give out these little cards which give the website address and my email address. So everything you want to know is there already. Okay, now, the introduction was about the mesh. And I started off with a mesh, and just that. I had 15 units up and running, and I discovered that I could talk to myself 15 times, because there was nobody else to talk to. So I stopped doing very much with a mesh, and started to build a backbone around Washington, D.C. So my goal now is to put up a microwave network owned and operated by radio amateurs around Washington, D.C. Okay? It's coming along fine. The Montgomery Group has agreed to put up units to all their repeaters so that it will cover the Washington, D.C. proper. There's a gentleman called Ken, what's his call sign? I've forgotten his call sign. Out in Haymarket, he has a large dish there. If you go to the website, there's a map up on the upper left-hand side, and you click on that map, and you'll see the units that are up right now and the ones that are planned. Last weekend, we put up a link in Red Lion, Pennsylvania, which we're now going to connect, probably when I get back from vacation, to the large tower in Frederick. I would say one of the people that I would say my Elmer, is a gentleman in Pennsylvania, Gary Blacksmith. He has 58 nodes in Pennsylvania. He started 5 years ago. So he's done everything I've done, he's done far more than I've done. And so I follow in his footsteps. And that's why the Red Line link is coming down to Frederick now. So I can see the link, probably this summer we'll have a link down to the Montgomery Club from Pennsylvania down to Montgomery and out to Haymarket. What's missing from this is someone on the east side and very far and south. I won't go into this too much because this presentation is long enough already. The map will explain it. Okay, so what I'm saying is my goal right now is to build a backbone because I want you to have mesh, but the mesh won't be able to talk to very many people if we don't get some kind of a backbone to connect things together. Okay, so I have a little question in the beginning. How many of you have heard of broadband HamNet? Okay, that's what the introduction was about. Okay, how many of you have heard of BC Warn or HamWAN? Okay, these are two you have. There's a group in Seattle, Washington. That's the HamWAN group. And there's a group in Vancouver, which is the BC Warn group. Now, both of these groups are strictly working with e-com, with hospitals and things and emergency stuff. They're not doing anything outside of that. How many of you heard of the bottom group, Central PA IP? That is a gentleman, Gary Blacksmith in Pennsylvania, that has 58 nodes, the largest one close to us. There is a little group, I shouldn't say little, I don't know, they have 4, I think they have 4 nodes in Baltimore. Brats has a group in Baltimore, which we'll hope to connect to when we get the stuff up in Frederick. Okay, this is what got me into this. These are the actual things I've just named right now. These are the groups that I've talked about, and a little map showing where they are. Okay, now this is what I want you to remember. The future's digital. Is there anyone here that doesn't believe the future's digital? Okay, I won't spend any time on that. Okay, the next one is about redundancy. When we talk about mesh, and you want to know really what the mesh is about, the essence of mesh is redundancy. A mesh is meaningless if you have 1, 2, or 3 units. It only really comes to its correct place if you have a lot of units. And that's one reason for building the backbone, is to get meshes, local meshes, and get them connected together. Because, and I'll talk more about that later. Okay, the red points are really important. What is amateur radio? That's one of the things I liked about your presentation so much. Amateur radio really are the people that are here. That's amateur radio. What frequencies you use, what equipment you use, that's all interesting, and that's what we like as technical people. But it's the knowledge we have that's really what's important. My goal is to get this backbone up. So what I want to do is I want to find people that have friends in high places, as we say. I want somebody that has towers, buildings, mountaintops, anything that's high so we can get line of sight. All right, the next point, bandwidth and regulated spectrum, is really interesting, and I'm going to mention it later. Any of you that think that Part 97 and Part 15 have nothing to do with each other, I've got to rethink that. The future, the FCC is going to change, in my opinion, completely how things are regulated. And I'll show you some examples that show that tendency of what's happening there. Just last week, the FCC opened up another segment of Part 15 down to 5.1 megahertz to expand the wireless network. The FCC has discovered that doing wireless, and I don't mean just the wireless you got home with your Wi-Fi, but doing wireless computer networks is the way to do it. Everybody, all the commercial people, everybody loves it, everybody wants it, everybody wants more bandwidth. So they're doing everything they can to use as much spectrum as they can in that area. And so they're continually expanding that part of it. So I'll talk about that more later. Okay, I haven't had it in a while, people would argue with me about how should this network look out. I can be perfectly honest with you. I really don't care how it looks. I just want it up. I don't want any arguments about how it should be. You can do it any way you want, just so we get it up, because that's the important thing. I very much see this as a little bit like the Wild West. I don't think regulations are going to save the spectrum for anybody. The only way to save the spectrum is you get an antenna up it, you get a frequency, and you use it. That is the only way to occupy the spectrum space, is to actually use it, because the telephone companies, everybody wants this space. So only by occupying it can you actually have any kind of guarantee that it'll work. Okay, now I'm getting back to the mesh now. So what is special about the mesh? You probably surely have heard from me about being self-configured, the shortest route, self-healing. The way this works, all these nice phrases, which are fantastic phrases, I mean, it's a fantastic thing, work because of redundancy. You can see on the right side where I've got a bunch of mesh nodes. There is no magic to this. If one of those units breaks, it's broken. End of story. But what the mesh does is it automatically switches to another unit. It was the same design that was in the internet. The thought with the internet, the reason it was built up the way it was because you don't want any single point of failure. And if you don't want single points of failure, the requirement is you have many points. The way it works is it switches to a different point. And this is why the self-healing and things work, is because these units are constantly transmitting and receiving from each other, exchanging information about each other. So if any one of them fails, it goes a different route. And it's even better than that. For example, if we say one of these units was taken over by someone that was mean or just wanted to be really nasty, and it started really swamping this network with a lot of data, these units are even so smart they can say, you're using too much. There must be something wrong, and actually can cut it down. So there are a lot of really nice automatic things to keep this working. It doesn't have to be a person, a tourist or anything. It can just be someone that wants to watch Netflix continually. Okay. All right, so this is what I'm talking about, redundancy. That's the key word. In this case, I've got a bunch of all these letters or nodes We're talking from A to G. G breaks down and it switches to another one. It's that simple, okay? But it's important. Redundancy is very difficult to achieve. Why? The first thing is nobody wants to pay for it. I worked at Fort Detrick. Everything's redundant. They order everything redundant. They lease two of everything, and they think everything's fine. What they miss is the telephone company A and telephone company B, which is supposed to be redundant. They're commercial, so they want to do as cheap as possible. So they actually ran both of their telephone systems to the same telephone pole, not from the base. A car hits that telephone pole, and there goes your redundancy. Okay? I would say, in principle, it's very difficult for an organization to buy redundancy, because whoever you're buying it from, you have no control over if it's really redundant once it leaves your area of control. And that's what I mean about redundancy being difficult. It's hard to guarantee. And that's where the amateur people really can help emergency communications. Because it doesn't matter what they do, putting up their own network or whatever it is, they can never really know if the redundancy they're paid for is really there. And where can it break? You know, a chain is only strong as its weakest link. So even if the chain is redundant everywhere and it's got one common link, that'll be the one that breaks. So redundancy is what's really important. Okay, and this, I want to say this a lot. It costs money, it's difficult to achieve, it's very difficult to verify. The only way to verify it is actually go out there and cut things off. So I would say that any emergency people should cut off their internet for one day and see what happens. To find out how useful is it if you don't have internet access. Okay, common point of failure. I've talked about this, so I won't go into too much. Testing is the only way to find out about redundancy. Okay, I've told you about before that none of this is sacred. For example, the group up in Seattle has a ring one, which is in the middle. They have a ring structure. Why do they have it? Because the way the mountains are around Seattle, they could build a nice ring around the city. Okay, it's only to do with practical things. There's no theoretical, not any really important theoretical reason for any of these. It really comes down to practical things. For example, the Montgomery group, their repeaters with a one in the center is sort of a star configuration, and they probably will set up their network that way first. But if you set up a star configuration, then your single point of failure will be the middle of that star. You don't want a single point of failure. So if they start that way, they probably should also connect sort of a ring around it, or have other, anyway, you've got the idea about redundancy and what I'm talking about. Okay, this is the way it started out with me. I'm up in Frederick. I started off, you know, I'm on my HF, and I started off with repeaters, and I get HF, and then I say, well, I'd like to get to 900 megahertz, and there's absolutely nobody in Frederick on 900 megahertz. I have to go all the way down to Washington almost. And then I went on 1.2 with the D-Star, the ID1, nobody up there on 1.2, too far away. So then I said, well, I'm getting sort of tired of this, but if I go up to 2 gigahertz and 5 gigahertz, surely I will find somebody. And that's where I got started with mesh. And like I said, I had 15 units talking to myself. Okay. So then I decided the only way to do this is to build a backbone and connect all these places. So I got a note up. I was very lucky. A gentleman in Braddock Heights said I can do anything I want up there in that mountain. So I'm putting stuff up there. There are quite a few towers in Gamble Mountain we can use. The W4BRM is over in Haymarket. He put up a sector dish there. But when you see the blue symbol up there that looks like, you know, a segment of a circle, that was really important. These are point-to-point antennas. A sector antenna, which I'll get back to that later because it's important. So this is what I want to do. Then I got down there your nodes. I really need as many people as we can to try to connect to this. That's it. It's not going to work otherwise. So I need all the help I can get. Damascus was another one. We connected from Braddock Heights to the Damascus Fire Department. That was a very nice event. Okay, now we talked about this. My introduction was, is this amateur radio? So this little section here is I want to show you some of my pet peeves about amateur radio, about repeaters, and why I'm not calling this a router, why I'm calling this a repeater plus plus. The reason is, if you look at everything in this site, I'll go faster because this is a long presentation. This is a repeater. It does all the RF things you're used to. In this case, it's digital, so it's very modern. You can put the internet over it because of the speed. That's only because of the bandwidth, and I'll talk about that later. But this is what the repeater is. If you look at this diagram, you can recognize everything. First, you've got your antenna, and you even notice you have a duplexer there. But one of the things about these small units, this is the router. I'll pass this around. I'll start the same way we did in this thing. Okay, you know there's no giant duplexer in there. And this is something that may come as a shock to you. You know why there's no duplexer in there? Because this is simplex. It never transmits and receives at the same time. But because it's computer controlled, it can switch between transmitting and receiving as fast as it wants. So that's why you never have these big units you see in the repeater, okay? Besides the frequency being high, but that's another thing, okay? So that's your regular transmit and receive antenna section over there. And then you've got your receiver here, okay? Everybody knows what's in your receiver. We won't talk about IFs and all of that stuff, but you know what it is, okay? Now on your transmitter side, you've got your basic oscillator. That has the exact same thing in there. And then finally, you've got your final amplifier. Now, to call that a final amplifier is stretching the word. That's 54 milliwatts, that unit, okay? So it's not much of a final amplifier. The largest unit I have is 1 watt, okay? So people say to me, well, I want to use part 97 because I can use 1,500 watts. Well, you've got 1,000 watts in your microwave at home, and you know what it's used for, so you don't want 1,000 watts in this thing. I can guarantee that. The gain of the 2-foot antennas is 30 dB, okay? I can put 1 watt into that, and I forget the exact numbers, but it comes out about 600 effective watts at the end of that parabolic antenna. So you can imagine what would happen if you put 1,000 watts in it. It would be a whacker. It wouldn't be a radio. Okay, so we don't need a lot of power. The FCC has approved going to 5 watts now with some of these, and that is a tremendous amount of power for microwave because of the gain of the antennas. Back to the repeater. So we got our final amplifier. So this is where things begin to get different. So if any of you have bought a radio recently, you might notice there may be an A to D converter or a D to A converter in it. Do you know what I'm talking about when I say an A to D converter or D to A converter? Do you? Okay? It's just the conversion from an analog signal to a digital signal. It's fairly simple, you know, and D to A is the digital analog and A to D is the analog to digital. Okay, so now we've got this over to a digital signal, but that doesn't help us very much with a digital. You know, we get a digital signal. Oh, I won't go into that. Okay, so this is where the next thing comes in. Also, if you bought a radio recently, you will probably notice a menu system in it. So there's a little bitty computer inside that radio to do all of this stuff that menu system goes to. So if you look at a modern radio, it's got all of these things here, and it's got a computer inside of it. And this is where you begin to see the thing on the repeater when you've got your controller for your repeater. Now, one of my pet peeves about a repeater, which I've never understood, is why in the world do I have to find out about a PL tone? I don't have to know a PL tone to get this to work. It broadcasts everything it's needed to know to another unit. The other unit receives that and says, oh, this is the way you work. I can work with you. I've never understood why repeaters don't do that, except for the fact that you buy old equipment and it doesn't have it in it. I expect if a new repeater was generated, and that's what I think it should do, it should tell the receivers about the PL tones and say, this is what you should be using. But that's just my pet peeve. But that's the reason I'm saying that here is because one of the differences between this and what you would say in a repeater is the level of automation. These units have so much computer power in them, they can do things like we're talking about, the PL tones and stuff. I'm using this symbolic. This doesn't have a PL tone, but the equivalent of that. So, if you look at a present-day repeater, you receive your transmitter, your duplexer, your PL tone. What did we add to this? In these units here, what do we add? Okay, it's computer compatible. That's the first thing. And all that means is you put the DDA converter in it, and you made it a piece of hardware in it so it can talk over this cable. That is extremely important. I'll come back to that again. Okay, collision management. How do you do collision management today? You say, I don't hear anybody, so now I can talk. That is collision management. This does it inside this box because you can't hear it. Network management. Okay, I don't know how many of you use Logbook of the World or log things, but you can now say, okay, you go on the internet and you start logging your communications and things. The same thing is happening inside of this, much faster because it's in your computer, about who do I talk to, how do I talk to, where they are, how far away are they. All of that information was in that mesh network. That's why it can reroute when things get broken, because all that information is saved inside the computer. And security. What is our way of handling security at the bottom now? We get annoyed, we call the FCC, or we get somebody to find them and tell them to get off the air. You can't do that in here, so again the computer takes that over. So what I'm talking about now is you have a repeater, and I call it a repeater plus plus, because you put a computer in it, and then everything we've done manually before is now automated. Why is it automated? First one, it needs to be done, but the other thing is speed. Having it automated, this thing can do unbelievably things very fast. Okay, now getting back to the RF side of this repeater plus plus. This is part 15 and part 97, and this is probably the most, I don't know, the thing I want to tell you is I personally don't see a difference between part 15 and part 97. Obviously there's a difference, okay, but we're hams. I think we use RF. That's what's important. You have the knowledge of the RF, you know how to use it. To me, that's the important thing. I think the regulations are going to change so that the shift between what's part 15 and part 97 is going to be pretty blurred in many ways. And I think hams should be experts in the spectrum RF period, regardless of what rule. Even if you use 93 or some other one. You know, if you're using Mars or something else, it's not important which regulation you're under. The important thing is your knowledge about RF and to make it available to whoever wants it, in my opinion. It's my opinion. Okay, so I've listed some of the bands here. There's a guy called David Byrne. He's doing some work on 900 and 450, and I'll come more into that, the lower things. Okay, this is what I talked about earlier about the 30 dB gain antenna giving you 600 watts down at the bottom. So there's a lot of power. Like I said, that other unit was only 54 milliwatts. I want to send away one more. This is Ubiquity. This is the same as the one you had before that I showed you. Another one I've taken apart. There's something else I would show you too, but it's holding up the projector, so we'll get to that later. All right, now, why is this important? Look at this. Look at the D-star speed here, 0.12 megabits per second. Look at the speed at the top, 24 to 150 megabits. Since I made this slide, Ubiquity now has 1 gigahertz at the top. Okay, they sell units the same price as these units that will give you 500 megabits per second. If you have the best you can buy at home from Verizon or Comcast, you maximum will have 30 megabits per second. I doubt, very seriously, if any of you have that, you may have 10 megabits per second. And it's a very big difference between your upload speed and your download speed. So these speeds are tremendously fast. And some people ask me, what do you want to use it for? Well, if you're at a hospital and you're going to send an x-ray, you want these kind of speeds because of the size of these documents, okay? So we're not just talking about forms and texting and those things. We're talking about images. I'm not talking about just pictures of people or I use x-rays as an example. So this speed is really important. It's the way the future is going to go. This is one reason that things are changing in the spectrum. Since everybody wants these speeds, the FCC has to make them available, and the only way to make them available is by taking everything, I would say everything above 400 megahertz. Because that's where you get the bandwidth we're after. So there'll be a lot of pressure there. Now, showing you what's important about this is I've listed here a lot of frequencies. And the one I want to tell you about is the 470. How many of you have heard about TV? Excuse me, by the way, I'm not facing you behind me. Okay, they do that. The TV white space. How many of you have heard of the TV white space? Okay, it's the space left. I don't know why they don't call it the black space. It's the space left when they moved all the TVs over to digital. Okay? And I don't remember the exact, but it goes, well, it theoretically be from 50 megahertz somewhere up, broken up to 800. But the one I'm interested in is this 470. What's happening now is they're now producing what I'm calling a repeater plus plus, or a router, on the 470 megahertz band. And why is that important? Because it's not line of sight. Everything I do is line of sight, and that is a real pity, let me tell you. So it's really nice if we can get down to these lower frequencies and do computer-compatible networks without line of sight. These units now cost about $6,000. And I figure as this becomes very popular, and they've sold it to everybody that has that kind of money, the prices are going to go down. And there are people trying to do the same thing in the amateur band, in 420. So I really think we're going to see a TCIP radio. And I'm not thinking of a D-Star radio, I'm thinking about down in 420 in the not too distant future, so we can get away from line of sight. Now it's not going to have 150 megabits. It may have 3 megabits, but 3 megabits is a lot more than 0.1 megabits of D-Star, okay? So a lot of technical things that are happening are going to get us away from the problem of line of sight, which I find really interesting.
It's not line of sight, what is it?
Well, line of sight is what you got on 2 meters or something, you know, it just goes everywhere, goes through the trees, goes through a lot of buildings. Line of sight is, I can go through a really small cluster at the top of trees with this thing here. If I've got a forest over there, I'm not going to get through it. And definitely not a building or a mountain.
So it's less than.
Yes, you know, so you want something that doesn't have to have line of sight. Okay, which is down at Now, even 900 begins to be a little bit, it's still on the flatter side. So you only get down to 420. But your bandwidth goes down, but will still be much better than you can get today. And this is, again, this has to do with the regulation change. The regulation restricts what we can do. That was a mistake. When you look with 20/20 vision, looking back at it, of what we can do with the idea of regulating the modes on a frequency has the weakness that the modes are a historical object. This is the modes we have. We moved over to computers now where we have different modes of modulation. The rules don't allow those modes of modulation. So it's much better, in my opinion, if the FC says these are your frequencies, this is the bandwidth you can use, and I don't care what mode you're in. Now that's what I'm talking about, the FCC. Then you got the ARRL, and us amateurs, we can decide what modes we want to use, and I think we should decide what modes we should use and what frequencies. And the FCC only tell us the frequency and the bandwidth we can use. That would give us the flexibility to change whatever the technology comes to in the future, because there's so much happening. Okay, now this is where I get to the, I told you this was my opinion, but I'm not the only...
This is an interesting subject that really applies to this report and probably anything else. You know, in the commercial sectors, where organizations pay for their spectrum, there is significant economic incentive to use the resource efficiently.
Did you hear that? It's a little weak. I'm sorry about that. For some reason, I never seem to be able to bring an amplifier with it. Okay, this FCC guy has this slide out. Look at what he's saying, bits per second per hertz. The FCC sees our spectrum the same way you see a quart of milk or a pound of meat. It's a certain unit that they're doing, and they want to maximize this. And you can almost see this being translated to a price, okay? Increased pressure, look at the word free. Free used to be a nice word. Now free's becoming it's becoming a four-letter word, okay? Because everybody pays for everything now. So the problem with free, I would say the FCC probably sees free as a problem because so many people want to pay. Okay, look at the bottom. The challenge is to adapt. I mean, just use the word adapt in general. This guy on this presentation, you should see the presentation, it's a long presentation. He says things like this a lot, saying that we're in competition with people that are willing to pay. Yeah.
Well, have they lost sight of experimentation and innovation then?
Okay, now if we put up this network, we're showing them that we're doing experimentation and stuff. That's one of the reasons for me pushing this. We've got to show them that we are doing that. And the only way to do that is to go to these places we haven't been before. And that, I think, is important, exactly that point. And he says it later in his presentation, that, we've got to show this. We can't just say it, we've got to do it. And this is one reason for going into these frequencies and using this technology, is to show that we can do this kind of stuff. Exactly right. Okay. All right, so now I'm stepping back to my presentation months and months ago when I was looking at the mesh. This is that router that I sent around, the Linksys router. It has to let you know how it works. First of all, how many of you know what SDR radio is? Software-defined radio, okay. This router is essentially a software-defined radio. You build a piece of hardware, you decide it's going to cover this frequency range, you say it's going to be able to use these kinds of modulations, and that's it. You don't have an interface on it, you don't have any buttons or knobs, and you build that, and then you hook a computer to it to decide all of this stuff. And that's what I call the repeater plus does. If you look up there, you'll see these channels. The blue one is the ISM band, the yellow one is the amateur band. So if we use that router, we can't use any of those channels which have the red line through them because they go outside of our band. So we can use everything in what turns out to be green, blue on top of yellow. But most of the time, you tell the software to use the first channel. So what's important about this, besides the frequencies and the bands, is that this thing is completely computer controlled. So whatever software you download in this decides what this radio does within its basic construction. And this is another peeve that I have against ICOM and these people. Why can't I download my own software into these radios? Okay? We're in a world now where we should be able to experiment, just like you're saying. You can't experiment if the hardware manufacturers don't give us the ability to change these things. And now everything is changeable in software. So that's something we have to demand in one sense. So this piece of hardware is completely controlled by software. So this stuff is changeable. Okay? For example, in this case, people in Texas made software that cuts out all the stuff in the blue region and gives us the stuff in the yellow region, just by changing the software. Okay, how far can we operate? I usually tell people, well, this thing here can easily reach Mars or Jupiter or another solar system if you just get it off the Earth. So it's not a technical problem of that device. The first problem that comes out, okay, is line of sight. The Earth is round, so if I shoot a straight line, at a certain point, it's not going to the Earth anymore. So that's the first limit of how far this can go. Okay? The other limit is that we've got air here. So this thing is going to get reflected and refracted in the air, off of buildings, tree, or whatever's around it. So all of these things are decreasing our signal length. Okay? So what do? The solution is you get this thing as high as you can, so it acts as if it was in space, so there's nothing in the way. So then it can go far. Okay? A clear path. It's very important. Line of sight, absolutely necessary with these things. Now, I want to mention this Fresnel zone down here, this blue area. Line of sight's not enough. That actual area should be cleared. So on the right side, when you see those trees, that'll probably work. That's not, I'm going to explain what it means when I say these things. The mountain at the bottom is probably a killer. It's probably not going to work there. But the one with the trees, it will work. So what does this come down to? This is the clue. First of all, if you use D-star anything, basically digital either works or it doesn't. That's the basic thing of it. Now let's say it works. The real question is how well it works. And here, what you're going to get is the distance depends on how well this communication is. If there's not a lot of refraction, not a lot of refraction, if the you all probably have heard about the cricket fence thing when you're traveling on the road with your VHF, where you get this fading in and out as the signal gets reflected, or if an airplane goes over and you're read from radio. All these are the different reflections, the signals coming from many sources, and I won't go into that too much, you understand that. Okay, so that's the problem here, really, inside of this blue zone, all right? So what happens is if I told you we had a guy up in Pennsylvania, and he has 100 megabits between all of his towers. If he puts up a tower that has a few trees in it, and too close to the ground, he may only get 10 megabits. So what happens is your rate of communication decreases. One of the main reasons it decreases is because this computer is sending that transmission, and it's saying, come back to me, and the coming back is a little bad, so it says, I got an error, and it retransmits. So if I start retransmitting every signal, immediately my bandwidth is cut in half. And if I got to retransmit again and again, it cuts down. So your throughput is cut down, mostly depending on the error rate. Because the computer will do its best to get through, but the rate will go down. So that's why this signal line is here. Once you've got the communication, the important thing is how well it works. It depends on these factors. There's something else I want to tell you there, but I forgot it. It's the thing in my mind. Okay, this is important. What do you offer? I want a network of mesh and a backbone to be completely privately owned by radio amateurs and clubs. I think that's really important. All right. Low cost of infrastructure. These units here come down in price all the time. The most expensive one of these I ever bought is $250. The radio unit was about $100, I think about $90 now, and then the biggest parabolic was maybe $120 or something like that. Anyway, it was $250 for the biggest two-foot unit. This unit here, I forgot to put the radio and this is the actual repeater, the router, and the dish come together. I can't remember the price of this. I think this is probably $110 or something, this unit, okay? So the price is really low, and it's continually coming down, all right? Okay. This is about, I've forgotten what this is. This is probably 200 milliwatts or something, okay? I've been in front of this for months. Okay. All right, so it's low cost. I wouldn't put the 2 meter one. That might be an issue. Okay, 600 watts might be disturbing. Okay, so it's low cost and we can do it. Okay. Now I want to say we're building a highway. People ask me what this is good for, and I don't spend a lot of time for that. But that's like me telling you what is a telephone good for. Okay, it's good for whatever you want to put over it. This network is good for whatever you want to put over this network. I gave you an example of X-rays, for example, because they need these bandwidths and stuff. But look what's happened with your telephones and everything today. I mean, there's continually new things coming. And I've got a slide which I think shows that best. All right, leveraging existing repeater sites. We've got sites, we've got high sites, we've got towers. It's really important. I went down to Reston and started going to a couple buildings down there and asking them, I'd like to put an antenna on your building. I met some really nice people that says, yes, you can do that. But I can't tell you because we now have a company that does that for us. So a company started, that company goes around to high buildings and say, I will lease out the top of your building. You give me the rights to the top of your building and I'll take care of the rest. So the company that now has the rights to the top of this building will lease it to me for $1,000 a month. An antenna. Okay. This is getting expensive, so our spaces on towers and repeaters is very valuable. Okay, and we really need to use it. It's really important. All right. And the last one, of course, I think is the real point: is we're experts at this. I have to admit, I mean, learning TCP and learning around and learning what IP addresses are and all that. It's a bummer in many ways, but it's the future. Okay, we've got to move into that. It's about your experimentation and stuff you were talking about. This is where it's at. Okay, this is where I started. And after I'd done this for a while, some people said to me, well, that's a piece of crap that makes this. These are much better. And I had to go back to them and say, that's not true at all. Where is the Linksys, by the way, now? Is it around? Because I want to show you. All right, if you take a look at this thing is really valuable in one sense. It only's got 54 milliwatts, so it doesn't go very far. Okay? But it's got 4 ports here. It's got a WAN port here, and it has 2 antennas. This thing, I don't know, it might cost you $30 at most nowadays. This, okay, costs twice as much as that. It has 1 connection on the bottom. So as soon as you use this, you're going to have to buy a switch, which immediately made it much more expensive than even this unit is. Okay? So this is why it's much more powerful. It has a lot of issues as far as hobby is concerned and learning to use it. This is a really good unit to learn on, because you won't get anything as cheap as this with this much functionality. It's not going to go further than a block or 2 away, but it's really good to learn on. Okay? That's what really makes that worthwhile. Okay? Okay, so I went to Ubiquiti. The reason I went to Ubiquiti, there were 2 choices. Ubiquiti's got the market for this on the East Coast and the West Coast. Another company called Microtech has a lot of units. I went with these because they were inexpensive. The company's really aggressive about that side of it. And I bought a lot of these units you see in this picture. I should remove this slide. I think this is really important. This unit has 3 networks in it. So when I talk about a network, it's really rough to use that word. This is one network. This is the amateur network. This is the RF network. Okay? This is the network if you hook it to the internet. Okay? This is your home network where you would have your computer and your printer. There are 3 networks. That's important because if you get them confused, it will really mess you up fairly quickly. Okay, what you're doing. What's it used for? It's a long list. This list could be very long. It says a lot here. Okay? I love DRAS. The guy showed me DRAS months ago now, and I really liked it because of what it did there. So I think a good thing for you to do is to set up DRAS and learn about it, what it does. It's just self-contained. It's sad that you put that name on it because it really doesn't have anything to do with D-Star. It's an excellent program, period, over TCP. Okay, telephone extensions. Out in the van out there, I've sort of directed that van to emergency communication. So I want to have all of these things inside that van. I don't have all of them there now, but I almost do. Okay? Okay, this is a love child. It didn't work a minute ago, so I'm not going to show it to you. But the reason I showed you this is this unit over here and the one over there. When I started this out a while back, I did a demonstration at the science exhibit in Montgomery County, their science fair. So I bought those telephones, I put that unit up, and everything was fine until, I forgot how old the guy was. He was maybe, I don't remember. My wife would remember how old he was. He was 10? What?
10, I think
10
it was.
He picks up the telephone, has no idea how to use it because he's never heard a dial tone in his life. He doesn't know what a dial tone is. Okay? So I bought the wrong telephones. It has to look like a mobile telephone. Okay? So I learned that lesson. But the reason I want to tell you about this device is the guy that did this, I really wanted to praise him. He took a router, okay? He took an ATM, which I no longer harm anyone. An ATM is an analog to digital analog converter, so you can use an analog phone on a digital network. He took a router and an ATM, put them in the same box, rebuilt the whole thing, and made what you see there, what's on that table over there. For the same price I could buy this, he gives you a complete telephone system. So what does he do with it? He sells it in Africa and South America to poor people that can't afford to use a cell phone. Most calls are local calls. They have the cell phone, but they can't afford to make the call on it because they're only going to talk to their grandmother 10 houses away. So he made this unit which you put up on these houses. They buy it once, and then the whole telephone system is free. A fantastic project. I think this is something churches and people that want to help poor people in developing countries, this is really a good thing. It uses mesh. This is a complete mesh system. You don't have any management. That's the real benefit of mesh, which I almost forgot. There's no management mesh. If someone walked in that door with a mesh unit, it would immediately connect up to my mesh system and work. Whereas if you go to the system with BC WAN or these other systems, which have the IP addresses and the routers and all that computer stuff, you have to have a network management to work. There's someone going to have to do a password, they're going to have to make sure the IP addresses are right. Yes, you have none of those problems. Okay, so where did I run into this in amateur radio? There was an exercise up in Maine where the guy brought these meshes. So if you need a local telephone system, you can buy those. They automatically work. I mean, this is a local system. We're not talking about miles here. But it gives you many connections on the telephone, which you could connect to some central PBX system or something. So it's really a nice system which uses mesh to do telephones. Okay, now when I started with this, if you look at the right side, you'll see my little tripod there with my antenna on it. It's not this antenna. I had my analog telephone on it. You see my camera, that's the same camera I had in the van. And I started out with that. And this is one of the other things I want to do is to put these up at marathons. Maybe I'm getting tired, whatever it was, another marathon coming up here. Marine Corps Marathon. Thank you very much. Okay, I'm going to send this book around. You don't have to buy it. It's on PDF on the web. It's free. Okay, the only reason I bought that copy of it is to be able to pass it around here. It is an excellent introduction. It probably covers the most width of any book without going too far in depth, but a good level of depth. So if you're new at this, go to the PDF thing on your web, look at that on the computer, and read about it. By the way, we'll just repeat, all this stuff is on the website, so you don't have to worry about it. It's all there. Okay, standards. When I meet people that know more than I do, and that happens fairly often, it happens more and more often, they talk about standards. And the only reason I put this slide up is to say that you've probably all heard about G and N on a router you have at home or something. And the only thing I want to say about that is these standards develop because of the capabilities of the hardware. But the other thing I wanted to point out was a specific case. The last one here, 11AC, that's a fairly new standard, which I don't own any of, but this company is now putting out. You see it says 500 megabits there. That's a new standard for that. The other standard, which I don't know if I have on the slide, is S, which is designed for mobile use. So when we're talking about these things, what these standards do, for example, a lesson I learned. I installed one of these. One of the parameters you turn on is how far away is the other unit? Well, I think, I'll say it's really far away because that must be better. Well, that was the stupidest thing I ever did. Because what does far away mean? It means the signal is going to take a long time. So this unit says, I'm going to have to wait a long time for that signal. So it actually doesn't try to communicate very fast because it figures it has to wait. So I made a big mistake. Now it will adjust it automatically, which I should have just said do automatically, because then what it does is it listens, it finds out how fast I can do it. This works, and it sets the rate it communicates with. Because when I said it was very far away, I forced it to put a very long latency, which means it waits a long time, and it could have been communicated. So this has to do with the things about learning what these things really mean. Okay? And that has to do with these standards as well. Like the S standard. If things are mobile, you've got to be prepared for a higher error rate. Okay, I started off here. I didn't bring it with me today, but you see the root tenor up at the top? If you're doing mesh and you've got one of these routers and you want to put it outside your house, the beauty of this panel antenna is you can open the panel antenna and mount this inside of it. So you get your box and a place outside your house in one time. So I really like that antenna. The middle one's a good antenna. I don't use it anymore. I think it's too heavy, so I don't carry it to my demos. Okay, so I use these lightweight, small ones. And I'm going to put up some Omnis now. In the van, I'm going to put up a couple Omni antennas because I expect to go around to a location like this. I was at a club up in Pennsylvania, I think there were like, at that meeting, there were 7 people that brought their mesh units with them, and they all immediately worked. And so that's the situation where I want to bring the van and immediately have anybody that has mesh connect to the van without having to do anything. Okay? All right, this is the inside of one of the units I passed around just to show you how it looks on the inside of it. These little, in the middle picture there, that's the actual antenna, a panel antenna. Okay, these are some of the things I experiment with. Out of the van, I want mobile computers, I want low power consumption, so I started looking at car PCs. There are a couple of PCs that have low power consumption. Really, they're the equivalent of a laptop put in a box so that it works like your PC at home. You can change the memory, you can change your hard disk, but it's basically a laptop. You've opened it up and got easier to access it. So I'm trying this one. This is not in the van now, but it will be. This shows that panel antenna I was telling you about. You can see down at the bottom where I'm now with the link system inside of it. That was one of the units I had before. This is my modern unit. This is the one I like here. So why did I go to this? I used, if any of you have looked at this before, I started off and I bought, how many of you heard of a Raspberry Pi? Okay, I bought a Raspberry Pi, I put asterisks on it, but in my first installation I used those telephones with asterisk PBX. That worked great. Asterisk is simple, it's really nice, but I'm also very lazy. I do a lot of these presentations, so I didn't want to have to manage anything, so I went to Grand Stream and I bought their PBX unit. It's this big, okay? I don't have to know anything. I plug it in, I plug these in, and it works. It's that simple, okay? Except for my klutzy fingers, it works. Oh. Okay, why does it work? It's not ringing over there? Don't put it in that one. I like touch screen, sort of. They tell me it's busy.
Right, we can hear it.
Did I put the telephone right?
Pretty good. Is the dish turned around?
It's a fast.
No, as long as it's red like that, it'll be okay. Like, it means it's got plenty of contact.
Usually if you get a fast busy, it's an error message.
Yeah, we'll see. Still says it's busy. Okay, why am I using these except for the dummy demo? You can see the screen of this. This is essentially the same as an iPad. You can, if it's connected to the internet, you can, look at Netflix, or you can use YouTube and everything else. And so this again is the future. When I have my pet peeves, I would like to know why ICOM hasn't done this. Okay, as these touch screens get bigger, I mean, ICOM came up with a touch screen now. Why not just go ahead and put everything you have in your iPhone, right, in your radio? I hope that doesn't upset anybody, but that's where we're going. These people did it. I think everybody will be doing that kind of stuff. So the PBX of this is in the van. Everything that's operating here is in the van. And we're connecting to it over this radio. And it's still got the colors. I won't show that up there. It's still got the colors on it, okay? So it's working. So my demos have gotten lazy in that respect. And I wanted to go to video and telephones. Okay, this is another one I had. Down on the left-hand side is another PC. This is essentially a laptop, which was designed to be used like a desktop computer. I won't spend much time on that. There's one other thing I've done. You'll notice on the right-hand side it says 3G network extender. I figured if you've got an e-com place, you want internet connectivity, you want to use all the things you've been using. You don't want to lose any of the things you're used to having. So with this network, I wanted the amateurs to supply internet connectivity. We say, like, when that tunnel broke down in Baltimore years and years ago, and we lost internet connectivity. It would really be nice if the amateurs supplied internet connectivity to all the fire stations and the e-com places, because we've got a private network that goes to Pennsylvania or Tennessee, where we could still do internet connectivity. So that's the first thing I wanted to do, is supply internet in emergency situations. The other thing I wanted to do is everybody uses their cell phone. And when those cell phone towers break, or they're overloaded and you can't get to your cell phone. So what I did was I put a Verizon 3G extender in the van. So if I have internet connectivity over this network to the van, I can give you 5 cell phones out of that van. So it's like a mini cell tower. Okay, now this may, some people, radio amateurs may say, but is this really amateur radio? Well, I showed you the repeater plus plus is amateur radio. But what amateur radio is, as you said, it's us supplying a service over RF. That's what we've got to do. And if that service is a cell phone or the internet or email, it doesn't matter. We've got to be able to do it. That's the experimentation coming again. Okay. All right, so now what I want you to think about this slide is look at the upper right-hand corner and the upper left-hand corner. I don't think anybody here would argue that the upper right-hand corner is not important. We use that contact all the time. The contact in the upper left-hand corner is equally important. The one on the right gives us power. The one on the left gives us a connection to everything we want to get connected to. And it's really important. It's really simple. TCP connector was an RJ45. All this equipment has it, and that is the most important thing. Yes?
That begs the question. Suppose the one on the right is inoperative. Your grid is down.
Yes.
You've got no power. What happens then?
Well, I could use a very interesting way of saying that, but I just bought a 2,000-watt generator for my van to solve that problem in my case. We've got to have them both.
But redundancy then.
Absolutely. The van, I mean, you got to have generators. The van has 2. It has the one in the van that's there without, and then the extra generator in the back, so I've got redundancy there. It has the shore power, so I've got 3 possibilities. But the amateurs at your repeaters, I don't know how your repeaters work. I assume you have a battery backup or something on the repeaters. We've got to have it. It's no use putting these things up on repeaters if the repeaters are going to fail, just like the telephone towers do. So we absolutely have to have reserve power at these places. How long and stuff is a whole other discussion. But it's exactly as important as for the repeaters. I mean, what I was reading, a cell phone tower is supposed to last 4 hours, and then they promise they'll come with a mobile tower or a generator. Well, I'd like to see that, how that works. We'll see how many of those they have. So I think you have to have reserve power as well. Yeah.
How much power do you need? Would a solar
Okay,
panel do this?
this one is 8 watts. Okay, so any of these units are easily powered with solar power without a problem at all. I mean, that's one of the really beauties about it. Because of the gain of the antenna, you don't have to have a lot of power. Okay. I've run one of these for 4 days on one battery because I haven't gotten power to the place on battery kites yet. But this week it's going to start. Okay, so the upper left and the upper right corner. Why is the earthquake detector there? Because I gave this presentation at the USGS, the Geological Survey, and they were very interested in using this for a lot of monitoring stuff they put out, so that's why the earthquake detector is there. The bottom stuff was new stuff that came out before. How many of you have heard of X10? Okay, so now you can think of what's happening. Everything you've ever seen on X10 is now coming on TCP. All the stuff across the bottom is really duplication and functionality you would have in an X10 unit, but it now runs over the an ether cable, or wireless if you got a router. So that's a big change that's coming. Okay, on the right side is a time server. I don't know how many of you have heard of a time server, but out in the van, I don't have any source to knowing what time it is really, so my computer could be wrong. That time server has a GPS on it, which gets the time from the GPS and sets the compute time in my van, so it has the right time. There are a lot of interesting things. I'm not going to go more into it, but this is, I mean, it's like the X10 stuff. A lot of stuff is coming for that. Okay, I don't spend a lot of time on this because I said I had 15 mesh units. I programmed them. I moved to Ubiquity. All of these things I'm telling you are far simpler than my ICOM menu system. Far simpler. I've never really learned my menu system. This is a much simpler thing. You go to the web, you go to YouTube, they tell you exactly how to do it, and you do it. Once you've done it, it's trivial to do. Okay? All right, this is my dream. The only thing that I haven't gotten, Anne Arundel isn't there, Baltimore has their own stuff, we're not connected to it. Hagerstown I haven't gotten to yet. I'm trying to get someone on South Mountain so I can connect to Hagerstown to get this done. As you see, there's not very much south here, okay? I really need stuff on the south side, so it's really important to find some connection. That connection to Haymarket. This is what I want to tell you. See that the blue sector down in Haymarket? What that guy did is he put up a sector antenna. Let me see if I got a sector antenna here. I'll show you a sector, well, it's coming up, I'll come back to that, okay. So let's go here. This is the Braddock Heights, Damascus, 18.2 miles with a 2-foot antenna, okay? To the fire department of Damascus, to my stuff up in Braddock Heights. Worked really nicely, $250 down at the fire station and $250 in Braddock Heights. I don't have my reserve power yet. I'm hoping I'll get that up in the next month, up in Braddock Heights. It's run on batteries now, really boring. You can see the picture up on the left-hand side. That's the 2-foot antenna. This is the other 2-foot antenna down at the fire station. That's the line. Okay. I do so much nowadays, I forget. How many of you ever use Google Earth? Don't need to say anymore. It's extremely important, okay? What you can do, in case you haven't discovered, is when you got that line on Google Earth, you can grab the end of the line and drag it around while you have that diagram at the bottom, so you can sort of like do a sweep of your paths and see what the possible paths around is. That'll work in real time for you. You also have a tool at the top of it to put a polygon out, so you can take 3 points of a polygon and actually just move it up and down on top of the earth to find all the high points. I do that a lot to find possible paths. Okay, this is the guy in Haymarket. That yellow sector over there is how far he can reach with one sector antenna. I'll show you the sector antenna. The one on the left was an experiment I did connecting to the red truck cross up in Frederick. Okay, the diameter of that circle, what that sector is 12.5 miles. So he can cover everything in 12.5 miles. The limits of the top of the left depend on the size of the sector antenna. Then he's in a little bitty hole up in the mountain, so he can't go north of that because he's got the mountain actually blocks him north. Okay, that's 140 square miles covered by that. So any amateur in that region that can put up one of these antennas, probably only 30 feet, that could get out through the trees, would be able to connect to him. I think that's a really good way to start out. Someone to put up a sector antenna high up, and then just see how many people in that area can connect. I'll show you more about sector antennas later. Okay, this is a path analysis program. You can see the Fresnel zone around it. This is a program that's on the web you can use. I can be honest with you, I've never used this program. The guys up in Pennsylvania use it all the time. Okay, we will start half to using it as we get more backbone stuff up, but now I've only taken really high points, so it hasn't been a problem for me. Okay, it will be. All right, this is something for communications people. It sort of misses the point.
When the 35W bridge collapsed last week, cell phone towers were overwhelmed in that area of Minneapolis.
But another high-tech communications tool kept people connected, and it's also helping with recovery operations over the last week. Carolyn Schnell Klein tonight showing you why city leaders have so much praise for Wi-Fi.
When the bridge went down Wednesday, cameras went up, and thanks to the wireless network the city of Minneapolis is building, emergency crews had an immediate view of the collapse.
That was unbelievable.
Though the Wi-Fi network so far only covers part of the city, it did include the 35W bridge. So since then, it's helping the city's emergency operations center closely monitor recovery. With one camera on the bridge and 2 on the riverbank, crews can from across the city zoom, pan, and tilt to see how to best respond.
We made sure the incident commanders that needed the resources the most got them first. On a radio call, you can't do that.
That was part of the reason city leaders say they wanted the Wi-Fi network, knowing it would not only be convenient for everyday computer users, but that it could be crucial in an emergency like this one. Administrators made the system free right after the collapse, and in 48 hours, the system's typical 1,000 users grew to 6,000. As residents logged on to communicate and get information.
Of course, you never hope for this type of thing, but it was a great demonstration of the power of this technology.
And that's not all it can do. As Wi-Fi phones become more common, this network could be a vital backup to cell phones, which were sometimes impossible to use last week as towers were jammed.
The wireless internet system is going to do tremendous things for citizens in this city.
Minneapolis leaders say the network is already being called a model for emergency preparedness, and cities across the country are looking into how they can build a similar system like Julie. Thank you, Janelle. Welcome.
Okay, now I showed this at one club a while back, and the guy says, "What, you want us to build a Wi-Fi network?" No, I don't want you to build a Wi-Fi network, but I do want you to build a private network that works as good as a Wi-Fi network, that can do everything it can do where it doesn't exist. I do want us to be able to do all of that stuff in our own private network. That I do want. But it doesn't have to, I don't want it open to the public. That I will say. Okay. Now going back to e-com. Now, I put these forms up. I have some of them on my website because these are really simple things to do, to supply these ICS forms over the system. You don't need a 150 megabyte system to do this kind of thing. This could work very nicely on a narrowband system. Okay, I put this up because of the narrowband emergency stuff at the top. I think we still need WinLink. We need all the things we can do with email for the non-line of sight things, but we can do all the other things where we have line of sight, okay? These are the two things I put at the bottom, which I told you about earlier. I think e-com people want what they're used to, and if they lose internet connectivity, something we should be able to provide it. Okay, this is just a piece of software. So what I run into with this is people say, I've got mesh things, and you've got ubiquity things or microtext things. What's the difference? I'm concentrating right now on the backbone, because if you do mesh, then you're not going to be able to talk to people in Frederick, or at least maybe not for my lifetime. But if I get the backbone up, you'll be able to talk to a mesh network in Pennsylvania or Frederick or anywhere else. Okay, this is important to get both of them built up. This software is the software that comes with these units, which is really good for building a backbone. Okay. This map is the one that's on the website in the upper left-hand corner if you click on it. The Pennsylvania network is the one at the top. He's got 58 nodes up there. The orange triangle at the bottom is the guy in Haymarket. The red lines are the one that exists. The one hay line going over where it says Germantown is the one to Damascus. At the bottom, Rockville is putting up one at the end of that orange thing down there out to the western repeater. And up in Frederick, there's a cluster up there where I'm putting up more nodes. I just put up another node last week. Okay, one more thing. You've heard this before. Oops. You've heard this before, but I just love this. If it works. This may not work because I don't remember what I did with the file about this. I'm not going to wait for it to come up anyway. What it was that beep I showed you before about aligning the antenna. Because people ask me, okay, there are two things you do when you put this out. One, the software in here, you say you do a spectral analysis. Would you show me all the frequencies here so you can find out what frequencies are not used? Okay, that's the first thing you do. The next thing you do is you go in for this program or one of the others and do a field strength study. The software is in the device where I can get the strength of the unit I'm connecting to. I can get the throughput to the unit I'm connecting to so you know how well it works. That's the software I was showing you here. The mesh software doesn't do that. The mesh is something local. I don't know. We're going to put our first mesh node up in Frederick now to see how far we can go with it. I think we should be able to do 12 miles in the mesh node as well, using ubiquity equipment, not using the Linksys stuff, because that's one of the advantages. Now they've done all of the ubiquity, all the Texas software now works in ubiquity devices. So we're going to try our first one. I've told you this before. I'm not going to spend time on it about what these units are for. This is my van. It's new. The idea with this van was that people ask me, for example, could I connect to Haymarket? What I do is I will come down tomorrow. I'm going to do that. I'm going to drive down to Manassas. We're going to drive around the van. We're going to see where we can connect to the Haymarket sector antenna. And then we'll say, okay, you can connect to it from here and somebody can put something out. These are the take-home points. Again, I just want to repeat them. The future's digital. You know it. Redundancy is really what it's about. We've got to have as many nodes as we can get up because we don't know where the failure is going to come, but we've got to have enough redundancy so we can work around that failure wherever it is. You are the important thing. Your knowledge about RF and stuff. We've got to have a backbone. I've sort of given you a little clue about the change in the regulations about frequencies and bandwidth as opposed to modes and things, and the pressure on the FCC to give space, high frequency space to other services. Okay, any questions?